June 4th, 1942, at 05:20 hours. The Pacific Ocean, northwest of Midway Atoll. The horizon was still dressed in the gray-blue shadows of pre-dawn. The USS Enterprise, her steel decks slick with saltwater spray, cut through the Pacific swells with the mechanical certainty of a warship at battle stations. Below the flight deck, in the dim, red-lit glow of the Combat Information Center, a young radar operator named Ensign Thomas Wardley sat hunched over a phosphorescent green screen no larger than a dinner plate. His eyes ached from the strain of staring at that ghostly circular sweep, watching the pale green line rotate endlessly like the hand of some supernatural clock. The equipment hummed with a low, insistent drone, a sound that had become the heartbeat of modern naval warfare, though few yet understood its rhythm. The air inside the CIC was thick and metallic, tasting of electrical ozone and human sweat. Every man in that compartment knew they were experimenting with something new, something the old salts of the Great War could never have imagined. On the screen, tiny blips appeared and disappeared like fireflies in summer darkness. Wardley's hand trembled slightly as he reached for the intercom switch. His voice, when it came, was steady despite the hammering of his heart. Radar contact, bearing 320, range 89 miles, multiple bogies inbound. In that moment, in that cramped steel chamber, lit only by the alien glow of cathode ray tubes, the ancient art of naval warfare shifted on its axis. For thousands of years, sailors had relied on their eyes, on lookouts perched high in crow's nests, squinting against sun and storm to spot enemy sails or smoke on the horizon. But on this morning, vision had been rendered obsolete. The Americans could see what the Japanese could not imagine, the future approaching at 200 miles per hour, still invisible to human eyes but perfectly clear on a screen that translated radio waves into tactical reality. The Japanese pilots, veterans of Pearl Harbor and the rampage through the South Pacific, climbed into their cockpits that morning with the confidence of warriors who had never known defeat. They had struck the American fleet at anchor. They had sunk the British battleships Prince of Wales and Repulse. They had swept the colonial powers from the Pacific with a speed and ferocity that shocked the world. These were not untested boys, but hardened combat aviators, men who had trained for years in the brutal crucible of the war in China. They expected to find the American carriers by the old methods, by scouting, by calculation, by the keen eyes of observers scanning endless miles of empty ocean. They expected a fair fight conducted by the ancient rules. They expected to see their enemy before their enemy saw them. They were wrong. The story of how radar transformed naval combat is not merely a tale of technology. It is a story of perception, of visibility and blindness, of how the ability to see beyond the horizon became the difference between triumph and annihilation. To understand what happened in the skies above Midway and in 100 other battles across the Pacific, we must first understand what existed before, the old world of naval warfare that radar would obliterate forever. For centuries, naval combat had been governed by a simple geometric reality. Whoever saw the enemy first held the advantage. Nelson at Trafalgar, Togo at Tsushima, Jellicoe at Jutland, all these admirals understood that the battle began not with the first broadside, but with the first sighting. Ships carried telescopes, trained lookouts, and flew observation aircraft precisely because vision defined victory. The side that spotted the enemy fleet first could choose whether to engage or withdraw, could position itself for attack, could mass its forces at the decisive point. But human vision, even aided by optics, possessed cruel limitations. A lookout standing watch at a height of 100 feet above the waterline could see approximately 12 miles to the horizon on a clear day. Bad weather, darkness, or haze reduced that range to almost nothing. Aircraft extended that range somewhat, but reconnaissance planes were few, their endurance limited, and their reports delayed by the time it took to return to the carrier and debrief. In the vast emptiness of the Pacific, where fleets might roam across millions of square miles, finding the enemy was like hunting phantoms. The Japanese understood this reality intimately. Their naval doctrine emphasized aggressive reconnaissance, superior optics, and the fanatical skill of their observers. Japanese binoculars were among the finest in the world. Their float planes ranged far ahead of their battle fleets. Their lookouts were trained to a standard of visual acuity that bordered on the superhuman. At the Battle of the Java Sea, Japanese spotters had identified Allied ships at distances that seemed impossible to Western observers. The Imperial Japanese Navy believed absolutely in the primacy of the human eye and the warrior's trained perception. American naval officers, by contrast, had begun to place their faith in something far stranger. The device was called radar, an acronym for radio detection and ranging, though its origins stretched back to the theoretical physics of the late 19th century. Heinrich Hertz had demonstrated that electromagnetic waves could be reflected by metallic objects. Scientists in multiple nations had experimented with radio echo detection throughout the 1930s. But it was the British, facing the existential threat of the Luftwaffe in 1940, who first deployed radar as a functioning combat system. The chain home network, those skeletal steel towers studded along Britain's coastline, had given Fighter Command the crucial minutes of warning that helped win the Battle of Britain. The Americans, watching Britain's survival with keen interest, had accelerated their own radar development. By 1941, the United States Navy had begun installing the CXAM radar system aboard its carriers and battleships. These early sets were primitive by later standards, bulky, temperamental, with limited range and resolution. The antenna arrays looked like massive bed springs mounted on rotating platforms. The displays were crude, showing only the range and bearing of contacts without altitude information. The equipment broke down frequently, required constant adjustment, and was so novel that many veteran officers dismissed it as an unreliable gadget. But the gadget could see through darkness, through clouds, through the very curvature of the Earth itself. The CXM operated on a frequency of around 200 megahertz, transmitting pulses of radio energy into the sky and receiving the faint echoes that bounced back from metal aircraft or ships. The time delay between transmission and echo revealed the distance to the target. The direction of the antenna when it received the echo revealed the bearing. Simple physics translated into tactical omniscience. An aircraft that was still 80 or 90 miles away, nearly an hour's flight time, appeared on the radar screen as a glowing dot. The radar operator could watch entire formations approach, could count the number of aircraft, could vector defending fighters to intercept with a precision impossible in the old world of visual searches. The Japanese had radar too. Their scientists were not blind to the technology. But the Imperial Japanese Navy had developed radar systems that were years behind American and British equivalents, both in performance and in tactical deployment. Japanese radar sets had shorter range, poorer reliability, and were fitted to fewer ships. More critically, Japanese naval doctrine had failed to integrate radar into combat procedures. It was treated as a supplementary tool, a backup to visual observation, rather than as the primary sensor it had become for the Americans. Japanese lookouts still scanned the horizon with their magnificent binoculars, while the radar screens, if they existed at all, were often monitored by junior technicians rather than integrated into the command structure. This doctrinal blindness would prove fatal. Return now to that morning of June 4, 1942. The Battle of Midway had reached its pivot point, though few yet understood what was happening. Admiral Chuichi Nagumo's carrier strike force, the Kido Butai, The same formation that had devastated Pearl Harbor was approximately 200 miles northwest of Midway Atoll. His four fleet carriers, Akagi, Kaga, Soryu, and Hiryu, represented the most powerful concentration of naval aviation in the world. Their decks were crowded with aircraft being rearmed and refueled for a second strike against Midway's defenses. Nagumo believed he was safe. His reconnaissance aircraft had found no American carriers in the vicinity. His staff calculated that even if American carriers were present, they would still be hundreds of miles away, too distant to pose an immediate threat. The admiral planned to recover his first strike wave, rearm his aircraft with armor-piercing bombs for anti-ship attack, and then hunt down the American fleet at his leisure. It was a reasonable calculation based on the old geometry of naval warfare, on the assumption that both sides were equally blind until visual contact was made. But 240 miles to the east, aboard the USS Enterprise, Hornet, and Yorktown, American radar operators had been tracking Japanese scout planes since before dawn. The American carriers had maintained radio silence, had refrained from launching early searches that might give away their position. Instead, they had relied on land-based patrol aircraft from Midway and on their radar's ability to detect enemy scouts before those scouts detected them. When a Japanese float plane finally spotted the American carriers and radioed a report, it was hours later than it should have been, hours that Nagumo could not afford to lose. The American carriers, meanwhile, had already launched their strike. Torpedo bombers, dive bombers, and fighters had taken off in the pre-dawn darkness, guided toward the Japanese fleet by radio navigation and by radar vectors that placed the enemy with eerie precision. The pilots flew not on hunches or visual searches, but on coordinates derived from electronic intelligence. They knew where they were going. They knew what they would find. The Japanese, despite their lookouts and their experience, never saw them coming. The tactical advantages of radar extended far beyond simple early warning. In the hands of the Americans, radar became a weapon of orchestration, a conductor's baton that could direct the entire symphony of naval combat. Fighter direction, the art of vectoring defending interceptors to meet incoming attackers, was transformed from guesswork into science. Before radar, defending fighters faced an impossible task. They had to patrol vast areas of sky, hoping to spot incoming bombers by chance or by visual signals from ships below. By the time lookouts spotted an enemy formation, that formation was often already too close for effective interception. Fighters would climb frantically, trying to gain altitude and position, but often arrived too late or in the wrong sector. The defender's advantage of operating near his own fleet was largely negated by the fog of war, by the difficulty of seeing clearly and communicating rapidly. Radar changed everything. Now a fighter director officer sitting in the Combat Information Center with his radar display before him could see the tactical situation with godlike clarity. He could watch friendly fighters taking off and climbing, watch enemy formations approaching from 70 miles away, calculate intercept courses with mathematical precision. Over the radio, in calm, measured tones, he could vector his fighters directly into the path of the attackers, positioning them for perfect interceptions. Blue section, this is home plate. Vector 340, Angels 20. You have bandits at 35 miles, you're 12 o'clock high. The fighter pilots, instead of searching blindly, could simply follow instructions and climb until the enemy appeared in their gun sights. The efficiency was staggering. Interception rates that had been 20 or 30% in earlier battles rose to 70, 80, sometimes 90%. Japanese attack formations, which had previously enjoyed the advantage of surprise, now found themselves intercepted far from their targets by fighters that seemed to know exactly where to find them. To the Japanese pilots, this appeared uncanny, almost supernatural. How did the American fighters always know where to be? How could they climb to the perfect altitude and arrive at the perfect moment? Some Japanese aviators began to suspect that the Americans had broken their codes, that spies were revealing their plans. The truth was both simpler and more devastating. The Americans could simply see them coming, watch them approach like insects crawling across a lighted map, and respond with calculated precision. The symbolic weight of radar extended beyond its tactical utility. It represented a fundamental philosophical divide between the Japanese and American approaches to warfare, a divide between the mysticism of warrior spirit and the pragmatism of technological systems. Japanese military culture, descended from the samurai tradition, placed enormous emphasis on spiritual cultivation, on the individual warrior's skill and determination. Pilots underwent training that was designed to forge them into living weapons through sheer force of will. They practiced gunnery until they could hit targets under any condition. They flew their aircraft to the edge of the performance envelope and beyond. They believed, with a fervor that approached religious conviction, that superior spirit could overcome material disadvantages. The phrase Yamato Damashi, the spirit of Japan, was invoked constantly, as if sheer courage could bend reality to the warrior's will. This philosophy had served Japan well in the early months of the war. Japanese pilots were indeed more experienced, better trained, and more aggressive than most of their early opponents. Their aircraft, like the legendary Zero fighter, could outmaneuver anything the Allies initially fielded. Their tactics, honed in China, were superior. They won their early victories through a combination of skill, surprise, and ruthless aggression. But spiritual fervor could not defeat electromagnetic radiation. Courage could not hide an aircraft from radio waves. The most skilled lookout in the Imperial Japanese Navy, scanning the horizon with perfect attention, could not see through 70 miles of atmosphere to spot incoming attackers. Yamato Damashi was magnificent, inspiring, and utterly irrelevant to a radar beam. The Americans, by contrast, had fully embraced what might be called the industrialization of warfare. They understood that war in the 20th century would be won not by individual heroism, but by systems, by logistics, by the ruthless application of technology and mass production. An American pilot did not need to be a superhuman warrior. He needed to be adequately trained, properly equipped, and slotted into a system that maximized his effectiveness. The system would do the seeing, the calculating, the coordinating. The pilot merely had to follow instructions and execute his role in the larger machine. This was not a matter of American soldiers being less brave or less skilled. It was a recognition that modern war had outgrown the ancient heroic model. A medieval knight, no matter how courageous, would die quickly on a modern battlefield. Similarly, a 1940s naval aviator, no matter how skilled, could not overcome the fundamental asymmetry created by radar. The Americans had accepted this reality and built their doctrine around it. The Japanese, trapped in a warrior culture that celebrated individual transcendence, struggled to adapt. The evidence of radar's dominance accumulated with each passing battle. At the Battle of the Eastern Solomons in August 1942, American radar detected the Japanese strike force at 75 miles, allowing defending fighters to intercept and shoot down dozens of attackers before they reached the American carriers. At the Battle of the Santa Cruz Islands in October, radar-directed fighters again intercepted Japanese formations far from the fleet, though in this case, enough attackers broke through to damage the Enterprise and sink the Hornet. But even in defeat, the Americans were learning, refining their procedures, integrating radar more completely into their defensive systems. The Japanese, meanwhile, grew increasingly frustrated. Their attack reports spoke of unusually effective American fighter defenses, of being intercepted unexpectedly at long range, of American fighters appearing as if they knew our approach vector. but the Japanese High Command struggled to understand what was happening. Intelligence reports mentioned American radar, but the technology was dismissed as inferior or unreliable. The notion that the Americans might have achieved a fundamental sensor advantage simply did not fit within the Japanese Navy's self-conception as the world's premier maritime power. As 1943 progressed, American radar technology improved dramatically. The new SG surface search radar could detect ships at 20 miles, even in darkness or foul weather. The SK air search radar extended detection ranges beyond 100 miles. Most revolutionary was the development of the VT proximity fuse, a miniature radar set packed into an anti-aircraft shell that would detonate automatically when it passed near an aircraft. This weapon, married to radar fire control systems, turned every heavy cruiser and battleship into a death zone for attacking aircraft. By 1944, American carriers were equipped with integrated combat information centers where radar operators, fighter directors, and gunnery officers worked side by side, sharing information through interconnected displays. The entire defensive system, detection, interception, and anti-aircraft fire, had been fused into a single coordinated response. Japanese formations attacking American task forces in 1944 faced a gauntlet that resembled nothing so much as an automated killing machine. The statistics tell the story with brutal clarity. In the Battle of the Philippine Sea in June 1944, known to American pilots as the Great Marianas Turkey Shoot, Japanese naval aviation was effectively annihilated. Of the 373 Japanese aircraft that attacked the American fleet, approximately 300 were shot down. American losses numbered 23 aircraft. The Japanese pilots, many of them inadequately trained replacements for the veterans lost in earlier battles, flew into a radar-directed defensive network that gave them almost no chance of survival. They were detected at maximum range, intercepted far from the fleet by radar-directed fighters, and those few who broke through were met by a curtain of radar-aimed anti-aircraft fire using proximity-fused shells. Consider the experience of a Japanese pilot. Let us imagine him as Petty Officer Takeshi Yamada, a fictional composite representing thousands of real men, attacking an American carrier task force in late 1944. Yamada is 21 years old, trained in 6 months rather than the 3 years that pre-war pilots received. He has logged perhaps 200 hours of flight time, barely half what his predecessors possessed. He climbs into his D-4Y Judy dive bomber knowing that the odds are against him, but sustained by the belief that his spirit and sacrifice will make a difference. His formation takes off from its land base and flies toward the coordinates where American carriers have been spotted. For the first hour of flight, everything seems normal. The ocean stretches endlessly below, blue-gray and empty. Yamada's eyes scan the horizon, looking for the telltale wakes of ships or the dark shapes of vessels against the water. His radio is silent except for terse navigation updates from his flight leader. Yamada does not know that 70 miles ahead, radar operators on the Essex and Lexington have been tracking his formation for 30 minutes. He does not know that fighter directors are already vectoring Hellcat fighters into intercept positions, placing them up-sun at superior altitude. He does not know that every gun on every ship in the task force is being aimed by radar fire control systems that have already calculated his approach vector. At 40 miles out, Yamada still sees nothing but empty ocean. His hands grip the control stick tightly. He is nervous but determined. He thinks of his family, of the Emperor, of the sacred duty he has sworn to fulfill. At 30 miles out, the first Hellcats arrive. They come from above and behind, out of the sun, positioned there by vectors from the Combat Information Center. Yamada's first indication of their presence is the tracer fire that suddenly rips through his formation. Aircraft around him explode or catch fire. The radio erupts with shouted warnings. Yamada throws his plane into a desperate dive, trying to evade, but the Hellcats are faster, better positioned, and guided by instructions from controllers who can see the entire tactical picture on their radar screens. Yamada survives this first interception, but half his formation is gone. The survivors push forward, now flying at wave-top height, hoping that low altitude will make them harder to track. But the American ship's surface search radar can detect them even here, skimming just above the waves. The task force commander knows exactly where they are, exactly when they will arrive. At 10 miles out, Yamada finally sees his targets, the gray shapes of American carriers surrounded by a screen of destroyers and cruisers. His heart surges. He has made it. He begins his attack run, pulling up to gain altitude for his dive. The sky around him fills with black flowers of exploding anti-aircraft shells. These are not the time-fused shells of earlier battles which exploded at preset altitudes. These are proximity-fused shells, each containing a miniature radar that detonates the warhead when it detects an aircraft nearby. The density of fire is staggering, a solid wall of steel fragments and explosive force. Yamada's dive bomber is hit multiple times. His windscreen shatters. His engine begins to smoke. He releases his bomb, wild, uncontrolled, and tries to pull out of his dive. The bomb falls harmlessly into the sea, one of dozens that will miss their targets that day. Yamada's aircraft, trailing smoke and fire, loses altitude. He attempts to turn back toward base, but his controls are failing. The ocean rushes up to meet him. In his final seconds, Yamada perhaps thinks of the training instructors who told him that spirit would overcome any obstacle, that the Japanese warrior was invincible if his heart was pure. He has done everything asked of him, has shown courage and devotion, has sacrificed his life for the Emperor. But courage is not armor against radar waves. Spirit cannot hide an aircraft from electronic detection. Yamada dies, one among thousands, in a war that has moved beyond the realm where such virtues matter. The recurring symbol that best represents the implacable advance of American technological warfare is not a weapon, but a sound. The steady mechanical sweep of the radar beam, that soft electronic hum in the Combat Information Center, the rhythmic pulse of the transmitter sending out its invisible fingers, became the heartbeat of American naval power. It was a sound the Japanese would never hear, a presence they could never perceive directly, yet it determined the outcome of every major carrier battle after Midway. Unlike the Zero fighter or the Long Lance torpedo, Japanese technological achievements that the Americans could see, understand, and counter, radar operated in a realm of physics that was invisible to direct perception. A Japanese sailor on a destroyer could see American aircraft overhead, could see the shells fired from American guns, could understand viscerally what he faced. But he could not see the radar beam that had detected his ship from beyond the horizon, could not perceive the electromagnetic energy that painted his vessel on a screen and called down destruction upon it. This invisibility gave radar an almost mystical quality. American commanders spoke of it in terms that mixed technical precision with something approaching awe. It was the edge, the long eye, the unseen advantage. Sailors who had experienced combat before radar and after radar understood that they had witnessed a fundamental transformation in warfare. Before radar, night combat was a confused melee conducted at close range by muzzle flashes and searchlights. After radar, night combat became an execution, with American ships detecting, tracking, and destroying Japanese vessels that had no idea they were under observation until the first shells arrived. The Battle of Cape St. George in November 1943 exemplified this new reality. American destroyers, guided by radar, intercepted a Japanese destroyer force in complete darkness. The Americans detected their opponents at 14 miles, maneuvered into perfect firing positions, and launched torpedoes before the Japanese even knew enemy ships were present. 3 Japanese destroyers were sunk. The Americans suffered no damage. The action lasted less than 30 minutes. Japanese survivors spoke of being ambushed by ghosts, of shells and torpedoes arriving from the darkness without warning. By 1945, American radar technology had advanced to include airborne early warning. Aircraft fitted with radar could orbit above the fleet, extending detection ranges to 200 miles or more. The days when a Japanese strike force could hope to achieve surprise against an American task force were gone completely. The Americans existed within a bubble of electromagnetic awareness that extended to every horizon, while the Japanese remained half-blind, dependent on fallible human vision and luck. The transformation extended beyond pure combat effectiveness. Radar changed the psychology of naval warfare, the fundamental experience of being at sea in wartime. American sailors, particularly those who served in the combat information centers, developed a new relationship with space and time. They could see events unfolding dozens of miles away. They could track storms, navigate in total darkness, avoid collisions without visual reference to other ships. The ocean, that ancient realm of uncertainty and hidden danger, became quantified, mapped, transformed into data streams and plotted coordinates. Japanese sailors, by contrast, continued to experience the war much as their predecessors had in earlier eras. They relied on their eyes, their instincts, their training. When death came, it often came without warning. A submarine torpedo from a boat they never detected, bombs from aircraft they hadn't seen until too late, shells from ships beyond visual range. The war became progressively more alien to them, less comprehensible, as if the rules of reality were changing in ways they couldn't perceive. This psychological dimension was not trivial. Combat effectiveness depends not merely on weapons, but on morale, on the soldier's belief that his actions matter, that skill and courage can make a difference. Japanese sailors in 1942 believed absolutely in their superiority and their destiny. By 1945, Japanese sailors understood that they were facing an enemy who could see in the dark, who knew where they were before they knew themselves, who could coordinate attacks with inhuman precision. The sense of helplessness this engendered, the feeling of fighting blindly against an omniscient opponent, corroded military effectiveness as surely as any material shortage. American intelligence officers interrogating Japanese prisoners noted a recurring theme in their testimony. The prisoners spoke of American special techniques and secret methods. They assumed, reasonably enough, that some extraordinary new technology or intelligence breakthrough was being employed against them, but they struggled to articulate what it was, because radar's effects were visible while its mechanism remained invisible to them. They saw the results: perfect interceptions, preemptive attacks, uncanny accuracy, without understanding the cause. Some Japanese officers, particularly those with technical training, began to grasp the truth. They studied captured American radar equipment, read intelligence reports, and understood that the Americans had achieved a decisive advantage in electronic warfare. But understanding the problem and solving it were different challenges. Japan lacked the industrial capacity to mass-produce radar sets comparable to American equipment. Japanese electronics manufacturing was years behind American capabilities. Even if Japan could have designed equivalent systems, the factories, the skilled labor, the reliable components necessary to build them in quantity did not exist. The evidence from declassified documents and post-war interviews provides quantitative support for these qualitative observations. American kill-to-loss ratios in air combat improved dramatically as radar-directed fighter interception became standard. In early 1942, the ratio was approximately 2-to-1 in favor of American pilots. By 1943, it had improved to 4-to-1. By 1944, in battles like the Philippine Sea, it reached 10-1 or higher. This improvement reflected not a sudden surge in pilot skill, but the systematic application of radar to fighter direction. Similarly, the success rate of Japanese air attacks against American carriers declined precipitously. At Coral Sea in May 1942, before American radar doctrine was fully developed, Japanese aircraft achieved multiple hits on the Lexington and Yorktown. By 1944, Japanese formations attacking American carriers routinely suffered 70 to 80% casualties while scoring few or no hits. The defensive system had become so effective that even massed kamikaze attacks in 1945, which required no accuracy beyond finding the target, struggled to penetrate to the carriers themselves. The transformation affected every aspect of naval operations. Anti-submarine warfare was revolutionized by radar-equipped aircraft that could detect surfaced submarines in darkness or through cloud cover. Shore bombardment became a precision operation, with radar-aimed naval gunfire supporting amphibious landings with devastating accuracy. Fleet logistics, the unglamorous but crucial task of keeping warships supplied across thousands of miles of ocean, became manageable through radar-assisted navigation and rendezvous procedures. Perhaps most tellingly, the American submarine force achieved its extraordinary success against Japanese merchant shipping in part through radar. American submarines in 1944 and 1945 carried surface search radar that allowed them to detect and track targets at night, when Japanese escorts were blind. Submerged attacks in daylight were dangerous. Surfaced attacks at night, guided by radar, allowed American submarines to approach, attack, and withdraw before the escorts could respond. Japanese merchant shipping losses mounted steadily, strangling Japan's war economy, and radar was one of the silent contributors to that strangulation. The Japanese response to this technological onslaught was characterized by desperation and a kind of tragic creativity. Unable to match American radar capabilities, Japanese commanders fell back on tactics that emphasized stealth, surprise, and individual sacrifice. Night attacks by surface forces, where radar advantage was reduced, became preferred. Airfields were hidden and dispersed. Supply convoys ran at night, hoping to evade detection. And ultimately, there was the kamikaze, the deliberate self-destruction that required no accuracy, no electronic guidance, only the willingness to die. The kamikaze tactic was in some sense an admission of technological defeat. If Japanese pilots could no longer penetrate American defenses through skill and coordination, then perhaps they could do so through sheer mass and the elimination of any requirement for survival. A kamikaze pilot did not need to release his bomb and escape. He simply needed to reach the target. This simplified the attack, reduced the training required, and paradoxically, made each attacking aircraft more dangerous because conventional defensive tactics assumed the attacker wanted to live. Yet even kamikaze attacks struggled against radar-directed defenses. Fighter directors vectored interceptors to destroy kamikazes before they reached the fleet. Radar-aimed anti-aircraft fire created kill zones that few aircraft could penetrate. The proximity-fused shells proved particularly effective against kamikazes, since a near miss was sufficient to destroy or disable an aircraft. Japanese casualties were horrendous, thousands of young men flying to certain death with minimal chance of success, while American losses, though real and tragic, remained manageable. The kamikaze represented the ultimate expression of Yamato Damashi taken to its logical conclusion. Spirit elevated above all material considerations. Sacrifice valued more than effectiveness. Death transformed into a weapon when life could no longer achieve victory. It was magnificent in its way, terrifying and awe-inspiring. But it could not defeat radar any more than traditional attacks could. The electromagnetic spectrum did not care about courage or sacrifice. It simply reflected back the radio waves that illuminated Japanese aircraft, marking them for destruction with impartial precision. As the war drew toward its inevitable conclusion, the technological gap between American and Japanese naval forces had become a chasm. American carriers in 1945 operated as floating fortresses, surrounded by layered defenses that made them nearly invulnerable to conventional attack. Radar-directed fighter patrols extended hundreds of miles from the fleet. Radar-aimed anti-aircraft fire created a kill zone within 10 miles of the carriers. Even the proximity-fused shells, those small marvels of miniaturized radar technology, represented a leap beyond anything Japan could produce in quantity. The final battles of the Pacific War, Iwo Jima, Okinawa, the bombardment of the Japanese home islands, demonstrated American naval supremacy so complete that it seemed to belong to a different war than the desperate battles of 1942. Japanese naval aviation had been annihilated. The surviving surface fleet was bottled up in port, immobilized by lack of fuel and fear of American air power. Japanese submarines, never equipped with effective radar, were hunted to near extinction by American anti-submarine forces that could detect them on the surface from miles away. The battleship Yamato, largest warship ever built, sortied on a suicide mission to Okinawa in April 1945. She was detected by American submarines and aircraft while still hundreds of miles from her target. American carrier aircraft attacked her in waves, guided to their target by radar-equipped search planes. The Yamato, magnificent and doomed, fought with desperate courage but never even saw the American carriers that destroyed her. She sank in less than 2 hours, taking most of her crew with her, a symbol of a naval philosophy rendered obsolete by technology she could not match. Post-war analysis by American and Japanese naval historians would confirm what had become obvious during the war itself. Radar had provided the Americans with a decisive advantage that the Japanese could never overcome. The advantage was not absolute. Radar could be jammed, deceived, or temporarily disrupted, but it was consistent and cumulative. In every battle, in every tactical situation, the Americans could see more clearly and respond more effectively. Over time, these incremental advantages compounded into overwhelming superiority. Japanese naval officers, writing their memoirs after the war, acknowledged this reality with the resignation of men who had fought bravely in a losing cause. Admiral Matomi Ugaki, commander of the 5th Air Fleet during the Kamikaze campaign, wrote in his diary of the frustration of sending men to attack an enemy who seemed to possess supernatural awareness. Captain Mitsuo Fuchida, who had led the Pearl Harbor attack, later described American radar as the most significant tactical advantage the Americans possessed, more important than their numerical superiority or industrial capacity, because it multiplied the effectiveness of every other asset. The epilogue to this story extends beyond the immediate tactical lessons of World War II. Radar represented not merely a single invention, but a fundamental shift in how humans could perceive and interact with their environment. The technology pioneered in the desperate struggles of 1940-1945 would become the foundation for modern air traffic control, weather forecasting, satellite navigation, and eventually the interconnected electronic networks that define contemporary warfare. The lesson the Americans learned, that systematic application of technology, integrated into doctrine and supported by industrial might, could overcome individual skill and fighting spirit, became a cornerstone of U.S. military philosophy. Every subsequent American military innovation, from precision-guided munitions to stealth technology to networked battlefield awareness, reflects this same principle. Create a system that allows adequately trained personnel to defeat even superior opponents through information dominance. The lesson the Japanese failed to learn in time, that modern warfare requires not merely brave warriors, but integrated systems of detection, communication, and coordination, cost them dearly. The Imperial Japanese Navy entered the war as perhaps the most capable surface fleet in the world, manned by superbly trained personnel operating excellent equipment. But they fought World War II with a World War I understanding of how naval combat worked, while the Americans had leaped forward into a new paradigm. Stand now in the Combat Information Center of a modern warship, the descendant of that cramped space aboard the Enterprise where Ensign Wardley watched his primitive radar screen on that June morning in 1942. The technology has evolved beyond recognition. Digital displays show a three-dimensional tactical picture extending hundreds of miles in every direction. Satellites provide reconnaissance from orbit. Networked sensors share information across entire fleets in real time. But the fundamental principle remains identical. Visibility is survival, awareness is victory, and the side that can see first and see farthest holds an advantage that skill and courage alone cannot overcome. The radar beam still sweeps, though now it is synthesized and digital, invisible even to those who operate it. But its descendants illuminate the modern battlefield with the same impartial certainty that revealed Japanese aircraft to American defenders across the Pacific. It is the sound of technological warfare, the steady electronic pulse that reminds us how profoundly science has transformed the ancient art of combat. And somewhere in the Pacific depths, in the corroded wreckage of hundreds of aircraft and dozens of ships, lie the remains of men who never saw what killed them, who died fighting bravely in a war that had already moved beyond their ability to comprehend. They were not defeated by cowardice or lack of skill. They were defeated by electromagnetic radiation propagating at the speed of light, by cathode ray tubes and rotating antennas, by a technology that rendered their training and courage and sacrifice irrelevant to the outcome they sought to achieve. This is the truth that radar revealed. That in modern war, perception defines reality, that the battle is won by whoever can see most clearly, and that no amount of warrior spirit can overcome the fundamental advantage of knowing where your enemy is while he remains blind to your location. It is a cold truth, unsympathetic to heroic narratives, but it is truth nonetheless, written in the records of battles won and lost, in the kill ratios that climbed steadily as technology advanced, in the testimony of survivors who spoke of feeling hunted by an invisible enemy. The Japanese pilots who flew against American carriers in 1944 and 1945 were brave men, flying to almost certain death in service of their country and their emperor. They deserved better than to be fed into a meat grinder of technological superiority they could not match. But history is not concerned with desert. History records only what happened. That radar changed naval combat forever, that the side which possessed it dominated the Pacific War, and that those who flew without it died in numbers that shocked even the victors. In the end, they never saw it coming. That is both their epitaph and the brutal lesson of how technology transforms warfare, suddenly, completely, and without mercy for those on the wrong side of the revolution.